last speaker of the day.
Right. I lost my card, so it's all up to you.
Oh, yeah, but I got my card. And Pietro, we know him from lots of things.
Yes.
Crasoleo, DocSOS, Fair Systems, core team. And currently, I need to read this, the infrastructure release security and response team. Right? So
That's
proud to introduce Pietro Albini. Yeah. Thanks a lot. Take it away.
Hi, everyone. We all deserve helpful tools. We deserve tools that when something goes wrong, tell us something went wrong. We deserve tools that when something goes wrong, tells us why it went wrong, and what are the causes, what are the context around it that helps us understand what is wrong. And we also deserve tools that when something goes wrong, try to help us. Try to point out possible suggestions, possible fixes, and guide us during debugging. And I'm sure we are all familiar with tools like this, because Rust is such a tool. The Rust compiler is so good at designing error messages and emitting correct and useful suggestions that I often like to call it your pair programmer that sits next to you and just helps you when something goes wrong. But this is not by chance. This is possible because Rust puts a lot of focus on error messages. It's one of the core principles of Rust. We had Alex early this morning that actually mentioned error messages as one of the major things. And that is not by chance. Rust's motto is empowering everyone to write reliable and efficient software. And I want to put focus on empowering. Because we are coming from a world where systems programming was only C and C++, only programming languages with a very steep learning curve. And Rust has one steep learning curve too. But the compiler, its error messages, help people let beginner understand their mistake and fix their mistake. And we are not alone in this. Rust is not the only tool that does it. It was not a tool that invented those, that pioneered error messages. A lot of the inspiration for what Rust does came from the Elm programming language, which is a functional programming language for the web frontend. But now that Rust got into the mainstream, now that Rust made it, its error messages are influencing all of the tools around us. Every year there is a new GCC release, and there's always this really nice blog post from Red Hat mentioning the new changes they made to error messages. And with giving something that, even though it's still not perfect, could still use a lot of work, is still miles better from where we were 5 years ago. This example in particular is from the latest GCC 15, where C++ template have kind of a tree-shaped structure when they're evaluated, and now they actually show those messages in this tree-like structure instead of trying to condense it into a linear message and creating a mess and a very confusing situation. GCC is not alone. Before working on Rust, Python was my main programming language. And there, in the last few years, there has been still improvements. It, again, might need some help. I would love some colors to just point out where things are. But in the last few releases, we now have Python that tells what part of the line caused the error, that gives you suggestion if maybe you just misspelled a variable name. And I cannot list all of the tools, either existing tools that has started to put focus on error messages, or new tools that are that are bringing fresh air, and along with the fresh air, better messages. But this is for tools written by others. What about you? How can you improve error messages in your project if you're developing a tool, a library, something other people use, or even just a side project for yourself? And this is what I want to cover today. How can we make error messages better? How can we make helpful tools? And I want to start doing it by looking at what Rust does. How does Rust do it? How are Rust error messages so good? And this is not a given, because having good error messages is actually really hard. Sure, sprinkling some color is a very quick win, but once you get into actually providing helpful suggestions, once you get into trying to put yourself in the shoes of your user and try to think, okay, if I were a beginner, where would I stumble and what would be the most helpful suggestion there? That is where it's really hard. But for us, errors are a core focus, are one of the pillars of how everything is done. When designing new features, we often think, how can error messages explain when this new feature goes wrong? And everyone on the compiler team cares about error messages. It's not just a few individuals that go around and fix the bad error messages everyone else on the compiler team made. It's a systemic concern to have good diagnostics. And everyone I know on the compiler team puts effort into that. And it's such a core focus that bad error messages are actually considered bugs. In the Rust issue tracker, there are now around like 10,000 open issues. Around a fifth of those, 2,000, are diagnostic error messages, diagnostic bugs about an error message that could be more helpful, that maybe gives an incorrect suggestion, or that with a small change will just elevate the experience for all of the users. And 2,000 is a lot, but the other number is that around 4.7K of those are actually already closed and fixed. And there is so much effort into that. So one of the ways Rust does it is just having it prioritized, having error messages be at the same level as, like, if a change is made, a change needs to have good error messages, the same way it needs to have tests, the same way it needs to be documented, the same way its code needs to be maintainable. It's a first-class concern. And going back to testing, Rust tests all of the error messages. And this is actually really important, because if you put a lot of focus on error messages and then an unrelated change makes them worse again, you wasted your time. If error messages are a first-class part of your software, they need to be tested like one. Rust's main test suite is called the UI test suite. And it currently has more than 19,000 tests. And those tests, that suite is called the UI test suite because it tests the UI of the compiler. It's made of 19,000 Rust programs, small Rust programs that are all compiled. And then we check whether the output of the compiler is what you expect. And if the test is supposed to pass, like if the program is supposed to compile, then the output, of course, is the banner that is executed. But if the test fails, then if the compilation is supposed to fail, then the output of the compiler is the error messages it gives. And that's what the UI test suite does, is it takes the output of each of those 19,000 tests and compares it with a known good copy of the error message. This is a technique that Rust did not invent. It's called snapshot testing, and it's useful not only when testing error messages, but in general whenever you do end-to-end tests and you need to assert on what the end result looks like. And if we just look at an example of how Rust does it, this is one of those test cases that in this case checks how casting between numbers and characters work. And we can see that it has three actual constant definitions. And the first two are supposed to error out. And there is a comment below them that in stock data suite, please expect an error from this line. But this is not enough, because sure, this error tests that the message contains only U8 can be cast into char. But what about the rest? Along with this test file, there is another file with an .stdr extension that contains exactly the output that the compiler is supposed to give to you. And if any of those bytes is emitted differently by the compiler, the test will fail. Having a bad error message is a test suite failure. Of course, in some cases, this is expected, and then there are some tools that the compiler team uses to update the known good copy. But often it happens that your change accidentally makes error messages worse, and this lets you notice that, this lets you fix that. So if you want to put focus on your errors, and I think you should make sure the error messages are tested. Same way you test everything. But Rust, it doesn't end here, because Rust has actually a disadvantage, is that it cannot control the quality of all its error messages, because when you misuse a library, the compiler cannot provide good error message information on how to best use that library. And we wanted to fix that, because since fairly recently, the Rust compiler allows us library authors to customize the error messages emitted by their library. And the same way that the Rust compiler team helps users of Rust have a good debugging experience, this lets library authors give their users a good debugging experience. This is done through the diagnostic tool namespace, which was an effort that, of course, as with everyone, every Rust feature was not developed by a lot of people, but was spearheaded by the maintainer of Diesel, Rust ORM that had a lot of complex error messages, and they wanted to improve those. The diagnostic tool namespace are a set of attributes that you can just put in your code, and if you're a library author and you're not aware of those, and your code uses a lot of traits, you should really look into, because let's just look at a few examples of what you can do with those. This is one of the error messages from the Diesel crate. And here, they are trying to query an integer and with a string. And that doesn't work because it is a type error. But the suggestion the compiler gives in the lower half is confusing and useless, because the compiler here actually tries to be too clever. And it finds that there is a less used implementation that might solve the problem, but is not actually what you want. So a thing we stabilized fairly recently is the diagnostic : do not recommend attribute that you can place on top of a trait implementation, and that will tell the compiler to never suggest that. This can be used in what is often called the pyramid of tuples, when a trait is implemented for tuples of variable length. With this attribute, you can avoid showing those. Or in this case, this is actually amazing, like removing that single trait implementation gave a useful error message, because it now said that the trait is implemented as expression integer is not implemented for a string, which is actually what you want. Another example is from the Bevy game engine, where they were trying to register a type. And here the error message is actually good. Like there is not it's not misleading. It says that the trait type registration is not implemented for the type, which is what's happening. But with diagnostic on implemented, library authors can customize every part of the error message that they display to the user. And so not only they can change the message of the error, so in this case, my component does not provide type registration information. They can also add custom notes. Below, you can see, consider annotating my component with derive reflect, which is something specific to Bevy. The compiler cannot figure that out. But since Bevy knows that is correct, having that line provides an invaluable help for new users of the library. And so if you're a library author, please consider looking into this to help your users. And if you are working on any other project that accepts third-party inputs like dependencies, libraries, or something, make sure those users can cooperate with you. to give better error messages. And so far, I talked good about Rust, good about its errors. But it's not always true. So what I want to do is take a bad error message, create a bad, cause a bad error message with you, and see how we can improve it together. See what the thought process that goes into providing good error message. So let's just bind to SQLite. SQLite is a C library to have databases, to have embedded databases. And given that it's a C library, if you want to bind to it, we need to create an FFI declaration. So this is how you do it in Rust. You import the required types, and you declare what the function should look like. Then we add the link attribute to tell the compiler to link to SQLite version 3, so that in the end it will be included in your program, even though it's not written in Rust. Then we just call the function. It has to be unsafe because Rust cannot verify the safety of a C library. And then we just do some error handling. And this looks like a normal Rust program. And if we try to compile it, we're going to get this error message, which is a linker error message that if you're familiar with C or C++, you're probably scared about them. And linkers are like a small part of the toolchain that is executed at the end and pieces together all of the parts, all of the compilation parts to create your final executable. And those tools have not really improved in their error messages since the 80s. So, which is a problem. So here C actually shows you the direct error message that the linker says, and then tries to be helpful, like, no, some external function couldn't be found. But this is just the case is actually wrong, because Rust doesn't have the information the linker has. So let's actually try to make this error message better, and let's focus on the error message the linker gives you. This is not a great error message, but let's go through it bit by bit. The first thing on the error message is the path to the linker itself. This is not really useful if you're trying to debug why a symbol is missing. So let's just ignore it. The next part is the object file that causes the failure. And this is something that, except for linker errors, you're never exposed to object files, because they're an implementation details of how the build works, of how your build system works, of how programs on Linux work under the hood. But this doesn't point to anything in your program. This doesn't give you any context on what caused the failure. So this also should be ignored. Then we get the first useful bit of information, which is the name of the function that caused the error. But again, this is not the most useful way to do it, because if you have a very large project, just having a type name doesn't let you easily go to where the error is, because it might be more complex. It might be complex to find the file. But let's keep it its useful information for once. Then it repeats the object name, because if you missed it before, you need to see it again, of course. And then we have where the error happened. And this is actually the exact location of the error, but it is possibly in the worst possible way you could express it. Because it points to the section of the executable that contains the error, and then the plus 0x28 is the offset of the assembly instruction that caused the error. I don't know about you, but my editor cannot open that. But it's information, let's keep it. Then we actually get to the actual error message, which is undefined reference to SQLite open, so something is wrong with it. And this is the error message, let's keep it. And finally, we have a line, which is an implementation detail of how linkers are invoked on Linux. And it doesn't serve any purpose whatsoever if you don't work on build systems. So this is also useless. And if you look at it, half of the error message it just doesn't help you. And actually, I would argue it's not only noise, it's actually actively harmful, because if you're a beginner, it's the first time you see a linker error, then what is .rcgu.o? What is collect to? What is this huge string of text? It just leads you to, it might lead you to go into the wrong rabbit hole and waste a lot of time in things that are not useful. So let's just remove all of those. This is already way better. So please make sure to remove all noise from the error message. Actually, it wasn't fully noise, because if you were working on a build system, some of that information might be useful, but very few people work actually on a build system. So if there is that kind of information, it might be useful to display, but hide it behind a verbose flag. Hide it behind something that, think of the audiences that will see your error, and think of what they would like to see. So these are already better, but let's continue to improve it. We can see that we have two ways of providing the location of the file. The function name that, as I said before, is not the best way to navigate through your source, and then the location in the object file, which is not great. Can we improve this? And the answer is yes, because that string of text, that huge string of text, is that because binaries, like your executables, contain information to turn that string of text into a line, into a file, and a line. This is the same thing that happens to display backtraces. So the linker knows it. The linker can use that information and provide this, which is slightly better than what we started with. So make sure that all of the information in error messages is actionable. That you can just take it and use it. You don't need to look how to convert that string into a file and a line. So we have this, which is better. Let's just sprinkle some color to it and maybe make it look more like RC. And this is not just like a stylistic tweak. This actually helps because it puts more emphasis with the colors, with the bold, on what the important part of the error message is. It allows you to scan it quicker. So colors let users focus on parts of the error message and have intrinsic meaning. If something is red, in most cultures, that means it's something problematic. So take care of using colors when the user interface supports it. It's not just a gimmick. And so we got that error message from where we were before. Can we do better? This is just we just reformatted what linkers emit now. Can we do something more? And turns out, yes. Because linkers are linking together your whole program with all of the libraries. They know all of the symbols, all of the functions that are present. Why can't linker just say, help, did you mean SQLite free open? Because that was actually the error that caused the program to fail. I forgot that in this SQLite free library, functions are prefixed with SQLite free instead of SQLite. If the linker said that, and that is something that it could take an hour to implement. It's not something that requires a major architecture of the linker. We'll save how many hours of people that just had a typo there and went into the wrong rabbit hole or had to open the documentation for the library and search for the function. This is way better. Can we do more? Turns out we can. Because on Linux, the way libraries are installed is standardized. And there is a file called package.config that tells you where each library is located. And this is shared across all Linux distributions. So what if the linker so let's say that the error was not caused by a typo, that I just forgot to link to the library. What if the linker just searches your system for libraries that contain that symbol? And tells you, hey, there's a library that actually provides the symbol you want, and here's the information on how to link to it. You should help your user. You should give them pointers on how to solve the problem, because that saves them time, because they don't have to look for the solution. But also, it helps users figure out which are not the most probable causes, where to go in their debugging experience, and save them a lot of time. And actually, the two suggestions I showed fix 2 of the 3 possible causes of linker errors caused by of undefined symbol errors from Rust programs. And having good suggestions for 2 of them, the third, of course, unfortunately requires a lot of cooperation between multiple parties, so it's harder. This saves users so much time. And the good thing is, all of this is actually possible. What I showed to you today are not just ideas in my head, are not just mock-ups I made. I actually implemented all of them. A while ago, I started working on Plinky, which is a very side project of mine to try to implement a new Linux linker from scratch. And to be clear, this is very much not a project announcement. Plinky is not ready, is not designed to be actually used, and I don't think it ever will. It's just a way for me to learn how linkers worked. At work, a year or 2 ago, I got to a point where I got a very confusing error message from a linker. And I spent days working on it. And after that, I realized I don't actually know about linkers. And so I just wanted to try to make one. So the code quality is not really good. I didn't know anything about linkers before. It's just a playground for me to experiment, to learn. But while doing that, I realized that linkers have access to so much information. Linkers have so many details about your program, about what they're doing, and they could put all of that in their messages, but they don't. It was so frustrating that I decided, okay, Plinky is not just a way for me to learn. It's also like a way for me to learn, to experiment on how to push the boundaries. If you actually want to contribute to a linker or want to use a linker written in Rust, don't use Plinky, to be clear. David Latimore made a talk earlier today about his Wild the Linker, which is an actual project that actually works. And so if you want to contribute to one, go talk to him. He's in the GoSim Spotlight area. Don't use Plinky, please. But this is not just about linkers. This applies to all tools. I focused today a lot about tool chains for programming languages because that's what I like to work on. That's what I'm familiar with. But I made these slides in types. Types is a new alternative to LaTeX, and its error messages, its compiler suggestions are miles ahead from what LaTeX does. And this is in a lot of new programs that are starting to be written now. And originally I wanted to say, and here are some libraries on how to write better error messages or all of that. But that is not actually a good suggestion because good error messages are not a technical problem. They're a prioritization problem. They are a social problem. There is no reason why linkers back then could not have error messages as good as we have them now. It was never a priority. The reason why Rust has such good error messages is because we put focus into that. We care about those. And you should put care into your errors. You should make sure that if you're developing a tool, if you're developing a project, either as a separate project or from your company, put care into error messages, prioritize their work, treat them as a first-class citizen. We all learned Rust, or are currently learning Rust. And I am right now fairly experienced in Rust. I know what is the cause of a lot of the error messages, so I don't care too much about how an error looks for Rust. But when I was learning Rust, they were invaluable. And all of the work that people did before me helped me learn Rust. And if you're currently learning Rust, I'm sure that is the same for you. So everyone before us helped us make good error messages. And I strongly believe that we owe it to the next generation of programmers to make tools even more helpful, to give them more suggestions, to give them good resources to debug, because we all deserve helpful tools. Thank you.
Amazing, Pietro.
Yeah, that's
Amazing.
fantastic. Yeah.
We wholeheartedly agree. We were like nodding along.
Yeah.
Yes.
I am blinded by the lights. I cannot see anyone.
We've been doing this all
Yeah.
day. No, but the first thing I thought was that in the olden days, sort of the fact that you get this error message and you don't understand, that means that you're obviously not smart enough to be programming in this language. This is certain sort of, I don't know what the word is, arrogance maybe, and I love that Rust is so much more helpful. I think it also says a lot about sort of the community and how it works together.
Yeah. Right. Should we move on to some questions from the audience? Where are the hands? Put them up high.
Yeah.
I see some over there.
Lots.
Amazing.
Almost.
2 hops.
This
All right.
one. Okay. So, with your suggestion about testing error messages in the test suite, I am worried about that becoming a scalability nightmare. So, can you say something about the tooling you mentioned in Rust compiler for updating those tests when you want to change the error messages?
Yes, absolutely. So like that is a tooling problem, and Rust solves this by Rust uses its own custom test infrastructure because a lot of the complexities of testing a compiler. Basically, the way it works is that there is a command line flag you can pass to the test suite called --bless to put your blessing on the new outputs of the tool or the new outputs of the errors, and then the test suite will automatically update the files. So if you make a change that changes 200 errors, you just do x test bless, and it will automatically update all of those. Outside of the Rust test suite, what I really recommend is using one of the snapshot testing libraries that exist in Rust, because all of the snapshot testing tools have a way to automatically update the blessed version of the output. So there are, for example, in Plink I use Insta, which is one of those libraries, and there after I change the error messages, I just do cargo insta accept, and it's going to update all of the saved examples. So here the only solution is to use one of the libraries that provide this.
Right.
And for the bad example you gave from the linker, all of that stuff probably wouldn't be noise to the developers of the tool because they might care about those details like the name of the object file and so on. So what are some good practices for maybe hiding unnecessary detail from the release version, but still maybe outputting it to help you debug issues for you as a developer of the tool?
So for the developers themselves, I would argue error messages are not user-facing error messages are not the way. Their logging might be more helpful because it not only includes context about the error, but what led to the error. And that is what the standard in the Rust ecosystem does with the Rust log environment variable when you can toggle on and off error messages. Another thing, because you need to think about the audiences of your errors, who is going to see them? In the linker example, an audience is all users compiling Rust programs. But another audience is authors of a build system where the name of the object file is actually really important, or the name of the symbol is really important. And there is no good solution because it needs what is the audience of your tool. For something that most people don't care and only a few people care, maybe putting a verbose flag might be helpful, so that, or say, if you want more information, pass -- verbose. It all depends on on who your users are and what do you expect most of the users to care about.
Right. Very good. Where's the catch box at? Has it moved?
Yeah.
Can't see it all. I just wanted
You
to
throw
say
it over there?
like I've been implementing a programming language and like I've been looking at Rust error messages a lot, and it surprised me based on like just sort of the feeling how terse they were sometimes, which is like so the part of like eliminating the noise really resonated with me. It's like yeah, like a good error message doesn't show you what you can't use. I thought it was lovely.
And those are really hard. Like, I cannot put enough emphasis of how much work and how much code goes into implementing the Rust error messages. Like, there are people whose only contributions to us, or most of their contributions to us, are just improving error messages. It's like, not trivial, but I think it's worth it.
Yeah. Fantastic.
Did the catchbox end up at the correct location?
Yes. Well, it ended at the correct location, and it was the same question, so it was passed on to me. I love the error messages in Rust, especially someone who's more of a learner. But as I understand it, a reason why Rust error messages can be so good is because the type system is so good. So maybe from the design of Rust, it's easier to know what's gone wrong. So prioritizing error messages, to what degree does that influence the implementation itself? Because maybe some information now has to be kept track of that didn't have to before, or maybe that places limitations on how good the error message can be. So how does wanting good error messages implicate itself in the development process itself?
Everywhere.
Okay.
Like, I mean, it's goes to what I said before. Like, there should be one core priority for you, because then like you don't add error messages the last minute, 10 hours before the release. You think about error messages while you implement the feature. And like some features in Rust had their design changed because of how do we teach this feature. And how do we teach this feature includes how can we explain when things go wrong, how can we design the error messages? Because it is a teaching problem in the end.
Yeah. Should we do one more?
One more.
One more.
One more.
Where's the box at?
If there is one.
Oh, I see box being held up high. Is there a question?
Yes. There.
I can't see
Excellent
anything.
location.
I don't know how you can see anything.
I can't.
Yeah, it's
Standing
more
on
like
the edge
a,
of the shade.
Oh,
yeah,
okay,
and now
okay.
I'm blinded again, and now this is
I
what I'm
think
doing
for-
all day long.
sorry. I think for me, one more like to make a remark rather than a question is I think, for example, for linker, it's important that if you compile for a C file, the object file name is very important, so you probably want to keep that. I think the important thing is actually, ideally, you will keep your error message structural so that it can be understood by another tool. For example, Rust C can generate error messages in JSON, which Cargo and Rust Analyzer can then parse and then emit it in their own format. So for example, the linker can include the object file in a field, and which, if the Rust C understands the linker, a structural error message from the linker, then it can just present this in a better way to the user.
Yes, absolutely. Like that is, I guess, an implementation detail, because from the point of the user, you still in Rust, you don't care about the object file. And also like, it's something that like is hard for interoperability, like because right now there is like GNU-LD, there is LLD, there is mold, we are creating wild, like we will need like to have all of those projects like agree on something, or like have every downstream tool implement support for 5 different linkers. It starts to become problematic, but like that's an option, and like that's an option I would like to see. More structured errors is one of the options now to do that.
Great closing words.
Very good.
Yeah.
Thank you very much, Pietro.
Yes. Also, if you are attending the 10 years of Rust celebration, I will be doing a release live at the release of the next Rust version, which is 187. So come see us, come see it.
Yeah, there's still tickets available, I think.
Yeah.
So you should all come and see a live release of Rust 187, right?
7.
187.